Alright, so please pause the video, try number 18 on your own, and then come back and check your answer. Alright, so we have three inequalities we're going to graph, and when we do this, it's going to form a triangle. And so, if you read the directions, it says graph each system of linear inequalities to form the stated shape. But then it says, find the approximate area of each shape by counting the squares. So after we graph it, we'll come back and we'll count the shapes. Alright, so let's graph the first one. It has a y-intercept of -1, and it has a slope of -4/3. And so when it's written like this, I just like to make just one of the numbers negative, because if you make them both negative, it turns into a positive. So down 4/3. And we're out of room, so let's go here and go up 4, left 3, up 4, go left 3. And so now, since this has a line underneath it, it's going to be a solid line. So since it's a solid line, I can use this. And now we can graph the other one. So when it's y less than or equal to 3, that's going to be a horizontal line at 3. So go up to 3. And it's just a line that goes straight across. And it has a line underneath it, so it's going to be a solid line. And so I have to go back to the red line for a minute because I forgot to shade. So since it's greater than, it's going to be above the line. So above the line, it's going to be this way. So now for the y is less than or equal to 3, the less than is going to be below the line in this way. And so now you can start seeing that there is some overlap. And now let's graph our last line. It has a y-intercept of -1, so they have the same y-intercept there. Now it has a positive 2/3 slope, so I'm going to go up 2/3, up 2/3, and then down 2 to the left 3, down 2 to the left 3. And so since it has a line underneath it, it's going to be a solid line. And so it's greater than, so it's going to be above the line. So now we're looking for where all three of these lines are intersecting at. And so what happens here is it makes this triangle and so what we want to do is so that's our answer for the graphing part. We've graphed all three lines, it's made that triangle. But then we have this extra step here of find the approximate area by counting the squares. So just count the squares now. So 1, 2, 3, 4, 5, 6, 7, 8. So what I'm going to try to do is only count almost complete squares. So I have 8, 9, 10, 11, 12, 13, 14, 15, 16. And now I'll start counting the other ones as half. So we're at 16. So these two will make 17. These two will make 18. This little piece and this little piece will be 19. And this piece and this piece will be 20. So I would say the area is approximately 20 units square. So it's 20 of those little square boxes. Alright, for number 19, we're going to graph the rectangle. So our first one is x is greater than or equal to -3. So since it's just x, it touches the x-axis at -3. So it's going to be a vertical line going here. And greater than, we'll be shading this way. Let's go ahead and graph the other one, the other vertical line. X is less than or equal to 1, so it's going to hit the X on 1. So it's just a vertical line here. And it's less than, so it's shaded this way. And so right now, this is the overlap. So now let's graph the horizontal lines. So y is greater than -4. And so since all these lines have lines underneath them, that means they're all solid. And this one is greater than, so we would be shading up, so in this area. And then the last one is at y at 3. And this one is less than, so I'd be shading down here. And so our shaded region would be where all 4 arrows intersect. And now, since this is a rectangle, we're not going to have any partial boxes, so all we need to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So the area here is equal to 28 square units. Now, would there be a better way for getting this one? Well, yeah, because this is 1, 2, 3, 4, so it has a width of 4 and a length of 7, so 7 times 4 is 28.